Today we're going to learn how to complete the square in order to solve a quadratic equation. So when we are solving quadratic equations, we're going to encounter some that cannot be solved by factoring. And a method called completing the square can be used when factoring cannot be done. So to complete the square of an expression that is in the form of x squared plus bx, what we have to do is we have to add the square of half the coefficient of x. So we're going to take half of b, so b is the value in front of x. We're going to take half of b and then square it. And that's what we are going to add, half of b squared. So let's look at an example. Let's say we have x squared minus 16x. So this is in the form of x squared minus bx, where b happens to be negative 16. So we'll take half of negative 16 squared. So that would be negative 16 divided by 2 is negative 8. And then negative 8 squared is 64. So again, we did half of b squared. So half of negative 16 squared. Half of negative 16 is negative 8. So negative 8 squared. And that is how we got 64. And that's what we'll add to the end. So now we have x squared minus 16x plus 64. Now it just so happens that x squared minus 16x plus 64 can be factored into x minus 8 times x minus 8, or x minus 8 squared. So anytime you complete the square, you're actually going to form a perfect square. Remember, perfect squares, you have your a squared, and then you have your square root, So if this is your first term, then this will be the square root of the first term. And if this is your last term, this will always be the square root of your last term. And then this will be the same operation in between, and then it will be squared. So anytime you complete the squared, it's going to form a perfect squared that can be factored. All right, let's do another example. Let's say we have x squared plus 3/5 x. So this is in the form of x squared plus bx, which means we can complete the square. So we need to take half of b, so half of 3/5. So half of 3/5 is the same as saying 1/2 times 3/5, which is 3/10. And then once we have 3/10, we need to square it. So that becomes 9 over 100. And that's what we have to add. So now we have x squared plus 3/5 x plus 9/10. So we know that this will create a perfect square, where our first term will be the square root of x squared, which is x. And then our operation is going to be the same operation as the first operation that appears. So it'll be plus. And then we do the square root of the last term, which just so happens to be the half of b. So half of b is 3/10. So 3/10 will go here. So this right here, this x squared plus 3/5 x plus 9/10 factors to x plus 3/10 squared. So the completing the square method can actually be used to solve any quadratic equation that's in the form of x squared plus bx plus c. So you just have to remember to add the same number to both sides of the equation. So for example, if we had 8x squared plus 8x plus 9, well, we would take half of the 8 and square it. So we're going to be adding 16 to both sides. So when we add 16 to both sides, we have to add 16 to the x squared plus 8x plus 16, which we know we'll factor in a minute. But we also have to add 16 to this 9. So now we have 9 plus 16 on this side. So then we'll factor that x squared plus 8x plus 16. That factors into x plus 4 squared, because it's a perfect square trinomial now. And then 9 plus 6 was 25. So now we have x plus 4 squared equals 25, which means we're ready to solve for x. So first we will square root both sides. And then that means we'll get x plus 4 is equal to plus or minus 5. Because remember, when you square root, you get the plus or minus. And then we will subtract 4 from both sides. So x is equal to negative 4 plus or minus 5, which would be 1 and negative 9. So just make sure that you check your answers. So if we were to plug in 1, we would have 1 plus 4, which is 5. 5 squared is 25. If we were to plug in negative 9 plus 4 is negative 5, and negative 5 squared is 25. So both of our solutions check. So these are your steps for solving quadratic equations by completing the square. First, write the equation in the form of x squared plus bx plus c. Then complete the square by adding the half of b squared to both sides of the equation. Then factor the trinomial, and then apply the square root property. So remember that's saying that if x squared equals n, then x is equal to plus or minus the square root of n. And then solve the resulting equations. So let's look at an example. Let's solve a squared minus 7a minus 3 equals 0. So the first thing we have to do is put it into x squared plus bx equals c form. So we have to add 3 to both sides to get it into that form. Now we can take half of b and square it. So our b is negative 7. So half of negative 7 is just negative 7 over 2. And then squaring that, we get 49 over 4. So we're going to add 49 over 4 to both sides. And so once we do that, we can factor that trinomial, and it will become a minus 7 over 2 squared. Remember, it's always going to be that half of b value right here, and this operation will always be the same here. And then 3 plus 49 over 4 is 61 over 4. Notice how I'm keeping with fractions for this problem. And then from here, now I can square root both sides using my property. And so I have a minus 7 over 2 equals plus or minus the square root of 61 over 4. The square root of 4 is 2, so that means I have plus or minus the square root of 61 over 2. Now I'm going to add 7 over 2 to both sides, which is great because our denominator is 2 here, and it will be a plus 7 over 2, which means that we can put it all under one fraction bar. So we have 7 plus or minus the square root of 61 over 2. If we were to approximate that with our calculator, we would get the decimals negative 0.41 and 7.41, and we can write it as a solution set using our set brackets. So next example is an example of our problem. We have a square garden. So x can be the length and the width. So x represents length and x represents width. They both are represented by x because it's a square, which means that they're going to be the same. And then we know that x plus 4 is the new width and x plus 7 is the new length. And then we know that the area of a square is length times width equals area. So that means x plus 7 times x plus 4 equals 550. We can go ahead and multiply binomials, and we get x squared plus 11x plus 28 equals 550. So to solve this, I want to put it into the x squared plus bx equals c form and then complete the square. So to put it into the x squared plus bx equals c form, I have to subtract 28 from both sides. And then I can complete the square by taking half of 11 and squaring it. So half of 11 squared is 121 over 4. So I'm going to add that to both sides. Then I'll factor that trinomial, and it's a perfect square, which means that it'll be the square root of my first term, which is x. I'll keep my first operation, and then it will be the square root of my last term, which is 11 over 2, which just happens to be the same as half the b value. So I have x plus 11 over 2 squared, and then 522 plus 121 over 4 is 2,209 over 4. Notice that I'm keeping with the fractions. So from here I can square root both sides, and then I can simplify. The square root of 2,209 is 47, and the square root of 4 is 2. Then I can subtract 11 over 2 from both sides. Just so happens that the denominators are the same, so that means I have negative 11 plus or minus 47 all over 2. then those two solutions would be 18 or negative 29. So if you're working with feet, you can't have negative 29 as a measurement. So that means that it's going to be 18 feet.